Hello dear friends, welcome to the lecture of geometry, and we are studying the straight line. Last time, in the last lecture, we have seen equations of a line passing through a point and having a given direction cosines and also direction ratios. Also we have studied 2-point form of equation of line, that means line passing through 2 points. In this lecture, we will solve some problems on these equations of a line. I have written here few problems and we shall solve them one by one. So the first problem is find the point where the line joining these 2 points cut the plane 2x plus y plus z is equal to 7. So we shall consider solution for the first problem. Here, these are the 2 points through which the line passes, and first we shall write the equation of line passing through these 2 points. Equations of the line passing through given points. Equations are, and how to write the equations using 2-point form we shall write. Consider this or we may use the earlier symmetrical form of equation of line passes through this point, and at the denominator we have to write the DRS of the line. So line passes through this point means this is x1 y1 z1 and this is x2 y2 z2. So we have the 2-point form as x minus x1 x minus 2 divided by x2 minus x1, that is 3 minus 2, is equal to y minus y1. We are taking this point, y minus minus 3, or that becomes plus 3. So y plus 3 divided by y2 minus y1, minus 4 minus of minus 3, and that is minus 4 plus 3, and is equal to z minus 1. Z minus 1 divided by z2 minus z1, 5 minus 1. So this is the 2-point form that we have written, x minus x1 divided by x2 minus x1, etc. And this can be simplified as, that is, x minus 2 divided by 1 is equal to y plus 3 divided by minus 1 and is equal to z minus 1 divided by 4. So these are the equations of the line. So these are the equations of the line passing through these 2 points, and we have to find out the point where this line cuts the given plane. Now these equations will be equal to some number, and we will suppose this is r. Say, why we are considering like this? Suppose this is equal to r. From that we will get a general point on the line or any point on the line, and that gives the coordinates x, y, z from this equations. So then any point on this line is given by, we will denote that general point as P and the coordinates x, y, z, and that this we have seen earlier. And how to write x value? Now equate this to r. Equate this to r, or we, instead of writing bracket, I will write directly equal to r. Say this r is assumed, and now from this equate the first and the last. So x minus 2 is equal to r. What is x? X will be r plus 2. So that is r plus 2. Now equate this second ratio with r, and we shall shift this cross multiply, minus 1 into r, that is minus r. Y plus 3 is minus r, and therefore y will be minus r minus 3. And what about z? This will be 4r plus 1. You can verify this. So any point on this line is given by this P coordinates, and we want to find point on this plane. So if this point lies on this plane, lie on the plane or lies on the plane, what is the equation of the plane? And see, that is 2x plus y plus z is equal to 7. Then we have, if the point lie on the plane, that means the point's coordinate must satisfy the equation of the plane, and we can write the value of x as r plus 2 etc., and the equation must be satisfied. So then we have this as 2 into x, x means r plus 2, plus y, that is minus r minus 3, and plus z, that is 4r plus 1 is equal to 7. Now we shall simplify this and get the value of r, and that gives, you see, 2r minus r, that is r, and this is 4r. So r plus 4r is 5r, and next is 4 minus 3, that is 1. 4 minus 3 is 1, and this 1, that is 2. 5r plus 2 is equal to 7, or that gives 5r is equal to 5, and therefore r is equal to 1. So thus we get the value of r, and now if you put this value of r on this point P, then that is the point which is on the plane, or that is the point of intersection of the line and the plane. So therefore, putting this in, we may suppose this as 1. Therefore from 1 the point is from 1 the point P is P equal to, say r is 1, so 1 plus 2 is 3, and this is minus 1 minus 3, that is minus 4, and last is 4 plus 1, 5. So this, the point P is this one. This is the point at which the line cuts the plane. This is the required point. So in this way we can solve the problem where the line cuts the plane. Actually the figure we have not drawn, but it will be of this type. See, this is a plane. This is a plane, and this may be considered as a line which cuts the plane at this point. So this is the line passing through given 2 points, and here is the point we have considered as P. So we have obtained the general coordinates of the point on the line, and if this point is on the plane, then it must satisfy the equation of the plane. That actually gives the value of r, and putting the value of r in this point, we get the required point. So this completes the solution of the first problem. Now we consider the solution of the second problem. See, the second problem, it is solution 2. Find the distance of the point, this point 3 minus 4, 5 from this plane. 2x plus 5y minus 6z is equal to 16. Measured along a line with direction cosines proportional to 2, 1, minus 2. So we will have a figure for this. Suppose this is the plane, and suppose this is a point here which is given 3 minus 4, 5. And the distance between this point and this plane is asked, but that is not perpendicular distance. It is the distance measured along line with DRS. Direction cosines proportional means DRS. And suppose the line may be of this type, and the line will cut or meet the plane at this point. It will proceed further, but we may show only this much. This is P. The line will cut the plane at this point, and so on. So we want to find out this distance. Find the distance of this point. Suppose this point is A and this point is B. First, we shall have to write, as in earlier case, the equation of line AP. So that means line passing through this point and having DRS 2, 1, minus 2. So that we will write equations of the line passing through. The point is 3, minus 4, 5 and having direction ratios. Actually, these are given direction ratios and not cosines, because these are proportional. Direction cosines proportional to direction ratios. Direction ratios are 2, 1, minus 2. So R. Now what are these equations? We know how to write it. So in earlier lecture we have studied how to write the equation of line having passing through given point and with DRS. So that is easy. X minus x1 means x minus 3 divided by the first ratio is 2 is equal to y minus y1, and y1 is minus 4. Minus of minus 4 becomes plus 4 divided by 1, and z minus z1, that is z minus 5 divided by minus 2. So these are the equations of the line, right line passing through that point and having DRS given. So we again assume this is equal to R, because we have to write a point, coordinate of a point on this line, general point on this line or any point on this line. So this is equal to R, and therefore coordinates of any point on this line are given by, that is again we can consider P as xyz, and this is equal to, find the value of x, equate the first ratio and the last number R. So we shift this 2 on that side, that becomes 2R, and shift minus 3, that becomes plus 3. So it is 2R plus 3 first y x coordinate, and y coordinate is R minus 4. Verify this, and this is minus 2R plus 5. So this is the point on the line, and again if this point P is on the plane, what is the equation of the plane? The equation of the plane is, this is 2x plus 5y minus 6z is equal to 16 is the equation of the plane, and therefore if this point lies on this plane, then it must satisfy the equation of the plane. So we can write, now I shall remove this first and write here. First problem I will remove. If this point P lies on the plane, the plane is 2x plus 5y minus 6z is equal to 16. Then we have, it is 2 into x, x means 2r plus 3, 2 into 2r plus 3, and further plus 5 into y, y coordinate is r minus 4, and minus 6 into z, z is minus 2r plus 5, and this is equal to 16. So further the simplification becomes, so I shall write here, that gives, now we will see what is the total R values. 4R plus 5R, that is 9R, 9R plus 12, 9 plus 12 is 21, 21R, and what is the constant here? It is 6 minus 9, 6 minus 20. 2 into 3 and then 20 minus 20 and this is minus 30. So that will be minus 50 plus 6, or 6 minus 50 is equal to 16. This 6 and this 6 cancels, the 10 remains on right side. So this gives 21R is equal to 10 plus 50, that is 60. You check it. And therefore R is 60 divided by 21, or that can be written in brief form. It is divisible by 3, so 20 by 7. This is the value of R. And now we have to put this value of R in P. So therefore the point P is from this. The point P is equal to R is 20 by 7. So it is 2 into 20, that is 40 by 7 plus 3. Then 20 by 7 minus 4 and minus 40 by 7 and plus 5. This is the point P. So thus we obtain the coordinate of the point P. But what is asked in the problem, you see, we have to find the distance of the point from this point measured along this line, means AP distance we have to find. And therefore the distance AP is to be obtained. Now A is this point. Now by the distance AP can be obtained by distance formula. The required distance is AP is by distance formula. AP, now you see A is here, 3 minus 4, 5, and P is here. So what is the distance formula? Under root of x2 minus x1 whole square, and that is 40 by 7 plus 3 minus 3 whole square, which is only 40 by 7. I shall write it directly, you should verify this. 40 by 7 plus y2 minus y1, 20 by 7 minus 4 minus 4, that this cancels in subtraction, minus 4 cancels. So it remains 20 by 7 whole square. And last also minus 40 by 7 plus 5 and minus 5, 5 cancels, minus 40 by 7 whole square. Now that can be simplified, and what is the simplification is square root of. See, the denominator is common, 7 square. So this is 40 square, that is 1600 plus 20 square 400, and again it is the same, square is positive, so therefore it is 1600 and divided by that is 49, 7 square, and this number is, see, 16 plus 16, 32 plus 4, 3600, or that is square root of 3600 divided by 49. And what is the square root of this? We know 60 divided by 7. So this is the required answer. AP is the distance along this line is 60 by 7. Now we will consider the third solution. Solution 3. Now what is the third problem? You see, find coordinates of the foot of the perpendicular drawn from origin to the plane. Also find the coordinates of the point which is image of the origin in the plane. So we shall draw the figure here again. Suppose for simplicity we will consider origin here, and suppose this is the plane given, and let us suppose origin is at this point O. The coordinates are 0, 0, 0, and we have to find the perpendicular, foot of perpendicular from origin. So this is, we suppose it is P, the foot of perpendicular from origin, and further see, find coordinates of the foot of perpendicular. P we have to find out from origin to this plane. Also find coordinates of the point which is image. So what is the image of the point in the plane? Means if O is this point, OP is perpendicular to the plane, and if you consider the extension of this perpendicular and let it be, say M, this point, then OP is equal to PM, then M is image, mirror image of this point O in the plane. That is the meaning. So first we will write this as an image. The image of a point in the plane is of or you can write of the point O is see, if is the point where which the plane bisects OM, or we say M is the image of the point, or the points O and M are said to be image of each other in the plane if OP bisects this OM, or P bisects the OM. If the perpendicular, it is bisected perpendicularly in the plane is the point M. Such that OP perpendicular the plane, or such that OM perpendicular plane and OM is bisected by P. That is, P is the midpoint of OM. That is the meaning. OM is bisected by P. Now before obtaining the coordinates of M, we shall have to obtain the coordinate of P as earlier. So, and to obtain the coordinates of P, we should have to write the equation of line OP. Now how to write equation of line OP? What is the equation of the plane? The equation of the plane is 2x. So this is the plane, 2x plus 3y minus 4z and plus 1 is equal to 0. This is the equation of the plane. So what are the, and we know, we have studied the plane earlier, and in this general equation of first degree, the coefficients of x, y, z represents the DRS of the normal to the plane, and therefore the DRS of the normal to the plane are 2, 3, minus 1, and normal to the plane is OP. So we can write the equation of line OP. Equations. So before that we may assume let the line cuts the plane at point P. Let the given line cuts the plane at point P. Therefore a perpendicular, and let OP perpendicular so actually it is given the coordinate foot of perpendicular. So therefore the DRS of OPR, the direction ratios of OP are the coefficients of x, y, z, and that are 2, 3, minus 4. and therefore equations of line OP will be. So this problem we have solved, second problem we have solved. So therefore I will remove the second problem and write the solution here. So direction ratios of OP are this, and therefore equations of line OP are passing through this origin and having DRS 2, 3, minus 4. So that will be x minus 0 divided by 2 is equal to y minus 0, this coordinates, divided by 3, and is equal to z minus 0 divided by minus 4. See this. Or that is simply x by 2 is equal to y by 3 is equal to z by minus 4. And we will suppose this is equal to r, suppose, and therefore a point can be written on this line. So therefore any point on this line will be, therefore any point on this line is p is equal to, p is x y z, and that is see, x is 2r, y is 3r, and z is minus 4r. And if this point P lies on this plane, then it must satisfy the equation of the plane. If we further consider, if this point lies on the plane, the plane is 2x plus 3y minus 4z plus 1 is equal to 0. Then we have, see, 2 into x, x is 2r, plus 3 into y, that is 3r, and minus 4 into z, z is minus 4r, plus 1 is equal to 0. Or from this we should get the value of r, and that is 4 plus 9, 13 plus 16. So 13 plus 16 is 29. 29 r, and what is the constant here is plus 1. So that can be shifted on right side. 29 r is equal to minus 1, and that gives r is equal to, therefore r is minus 1 by 29, and thus from this r we can get the foot of perpendicular. So it is asked find the coordinates of the point, see, from this find the foot of perpendicular. So therefore the foot of perpendicular is P, and P is equal to, now you see, P is what are the coordinates? 2r, and this is to be multiplied by 2, that is minus 2 by 29, and 3r y coordinate minus 3 by 29, and minus 4 times r, minus of minus becomes plus 4 by 29. So this is the foot of perpendicular from this origin to the plane. And what next asked is the image of the origin in the plane, and image is M. So P is the midpoint of OM. So if M is the image, or let M is equal to x1, y1, z1 be the image of origin O in the plane, then P is the midpoint. P will be midpoint of OM. And therefore by midpoint formula we can write this as midpoint formula or distance formula. So the midpoint's coordinates are these as P, and that gives minus 2 by 29, minus 3 by 29 and 4 by 29. So this is equal to this midpoint of O and M. O and M are here, 0 plus x1 divided by 2. Midpoint formula, 0 plus y1 divided by 2 and 0 plus z1 divided by 2. So that gives, and from this we can easily obtain M, x1, y1, z1. So therefore M is x1, so multiply by 2, that is minus 4 by 29, multiply this by 2, that is minus 6 by 29, and multiply this by 2, that is 8 by 29, is the image of the origin O in the plane. So this gives this completes the solution. So thus we have solved the problem. From origin we have obtained the equation of the line, perpendicular line to the plane, and then we have obtained the foot of perpendicular coordinates of P, and then we have obtained the coordinates of M. So thus this completes the solution for the third problem. Now fourth and fifth problem I will leave for you to solve, and you should try these problems. Try to solve these problems yourself. I have written the answer here. Find the coordinates of the point of intersection of this line and this plane. We have solved such type of problem earlier. So let this be equal to r, write general point, and that point is on the plane, gives the value of r, and then from that you can get this point. And next one is find 2 points on this line. Find 2 points on this line on either side of this point and at a distance 3 from it. So the meaning of this is a line is given for the fifth problem. Suppose this is the line and this is a point on the line. Suppose that point is A. A is a point 2 minus 3 minus 5. You can verify this satisfies the equation, and we have to find a point on either side of this at a distance 3 unit. That means if the point may be considered as P 3 unit distance, then another point will be at Q 3 unit distance. Or you consider first this single point, then we have to find a point P such that AP is equal to 3. Here, so write the coordinates of P from the equation of the line, and then solve AP is equal to 3. Use distance formula, and that gives 2 values of R, and that 2 values gives the 2 coordinates, and we may suppose that as a P or P1 and P2. So in this way this problem can be solved. So please try to solve the fourth and fifth problem yourself. The remaining part we will continue in the next lecture. Thank you.